Right, we are going to work on chapter 2 on this video. Chapter 2 is a little bit long. It has a section 2.1 all the way up to 2.7. So I'm going to break it into half. So in this video, I'm going to go through 2.1 all the way up to 2.4. And on the next video, I'm going to lecture 2.5 to 2.7. So let's pull out chapter 2 notes to the very beginning page. And go through 2.1 to 2.4. First part of chapter 2 deals with organizing data. A little bit of chapter 1. Last video I talked about how to organize data by creating a bar graph and then pie chart and then frequency table. Now there are a couple more ways to organize the data besides those. First one is called stem and leaf graph, and we are also going to look at the line graph and then more types of bar graph. Stem plot, also known as a stem and leaf graph. What is it? It represents the quantitative data. Again, we talked about quantitative versus qualitative last time. Quantitative is a data involving a number, right? Numbers. So you're going to see the numbers involved. By separating into two parts, the stem, such as the leftmost digit, the leaf, such as the rightmost digit. So here's an example of a stem plot. Here, the left side number, these are the stem, and then this part over here is the leaf. Oops. Leaf. Okay. Advantage. We can see the distribution of the data while keeping the original data value. I'll talk about this in a minute. So how do you interpret this data? This is going back to that IQ score data that we worked on in chapter 1. So this is how you interpret this data. On the first stem and leaf, there's a value IQ score of 85 because there's a 5, and there's 2 7, so you have a 87, 87, 88, and 89. Okay, that's how you interpret the data. The second one, you have a 93, 94, 96, 96, 96, 97, and then 101, 101, 103, 103, 113, 114, 126, 124, 126, 127. Okay, now so the advantage says we can see the distribution of the data while keeping the original data value. Now, if you rotate your paper and then look at it, you're gonna see that the distribution, the distribution, it's hard for me to rotate the paper. It automatically flips the screen. But you can see there's a peak going high and then it goes down if you're trying to graph it, right? So you can see that most of the data are on the left-hand side, and then there's a more spread out of the data. So you see the distribution, but also you see the original data value. You can actually see that, oh, there's an IQ score of 85, 287, 88, 89. So this is nice. The second is side-by-side stem and leaf plot. This is just the stem. This is a compare between the two data sets. Instead of creating like a one stem plot and then another stem plot for the second set, you're basically using one stem to make a two leaf. So here you have a two different data representing presidential age in inauguration, and then another data set with the presidential age at death. So they create the stem. This part is your stem. And there's a two leaf, one on the left and then one on the right. One on the left represent ages at inauguration. So you're going to see the this part here. And then the right hand side represent all the data that is a presidential age at death. Now to interpret it, starting from the left hand side, you're going to read 42, 43, 46, 47, 47, 47, 48, 49, 49, not 94, 94, 84, okay? You start with the stem and then spread it out. So let's just double check. Do we have an age, only one age of 42 at ages at inauguration? Well, let's find out. 42. Yep, the Roosevelt is the 42. Let's just check one more time. There should be a 47 three datas. So where are the 47s? Here, Clinton, Obama, and Cleveland. So you can see that as well. Same thing, ages at death. We have a 46, 49, and then 53, 56, 56, 57, 57, 58. Let's just double check. There should be a one data of 46, which is Kennedy. Okay, so that's one way to organize the data. Let's go to the next page. Histogram, frequency polygon, and time series graph. These are the additional graph that you can make with the data. Histogram, this is a type of a bar graph in which horizontal scale represent the classes of values. So horizontal scale classes, and then the vertical scale represent the frequency. The height of a bar corresponds to the frequency value, and then bars are drawn adjacent to each other without gap. In chapter 1, I'm going to pull out chapter 1 notes. There was a bar graph here too, but you can see that there's a gap, right? And then underneath, you have this word, the graph may or may not have a gap. Histogram is one without the gap. So one without the gap, we call it histogram. Okay, so that's the only difference. If you have a gap, we call it bar graph. If there's no gap between each bar, we call it a histogram. And this is just note the horizontal scale represent the class boundaries or class midpoints. Vertical scale represent class frequency. The vertical axis should start at 0. This will always start at 0 because there could be a 0 data, like no data shown at that class. But horizontal axis can start at any number. You can see that it starts at 80. There's no need to go all the way from 0 to label this because there's really not data of IQ score 0. So they started out as 80 all the way up to 130. Frequency polygon. What is a frequency polygon? Frequency polygon is basically a line graph. You have probably seen the line graph before. The x-axis represent the horizontal scale, and then the y-axis represent the frequency. So here, if you look at this data, in a survey of 40 mothers were asked how many times per week a teenager must be reminded to do his or her chores. We have a 0 number times, 2 frequency, 1 time 5, 2 times 8, and so on. So you have 0 and then put a dot at 2, 1, you have 5 because the frequency is 5. So you locate the dots and then basically connect each dot to create the line graph. Okay. Time series graph. What is a time series graph? It's very similar to frequency polygon, except the time series graph represent the line segment connected to quantitative data that have been collected at different points in time, such as monthly or yearly. So basically, instead of your horizontal scale will represent a time. Okay, so example, let's say number of times car crash over the years, number of year. So this horizontal scale represent the time. That's the only difference. So 2000, 2001, 2002, 2003. Then I'm just making a number, some kind of data values. Then you just connect the dots. Okay. So 2.1, 2.2 is just organizing the data. Now 2.3, we are going to start analyzing the data. We're going to look at the location of the data values. Now we have a concept of percentile, quartile, and then inner quartile range. Now this part over here is the opposite of finding the percentile. So let me talk about percentile first. What is a percentile? Measures of the location denoted P1, P2, P3 all the way up to P99, which divides a set of data into 100 groups with about 1% of values in each group. So basically when we say the 50th percentile, that's a piece of 50. That means it has about 50% data value below and 50% data value above it. If it's P3, that means 3% of data value below that X, whatever the X is. And then, so it's a 3, so 97% of data values above it. The formula for finding the percentile of a value X is X plus 0.5 times Y over sample size N times 100. Now multiplying by 100 will make this number into a percentage value. Then we are going to round to the nearest integer. To the nearest integer. Okay. What does X represent? It's the number of data value counting from bottom of the data list up to, but not including the data value for which you want to find the percentile. Y represent the number of data values equal to the data value for which you want to find the percentile, and represent the total number of value. Now I'm just gonna go through this page that give you all the formula. I know it's a little bit confusing without an example, but actually on the next page, in this example, I'm gonna go through all the percentile, quartiles, and then going over the outliers. Okay, so just bear with me going through the formulas. What is a quartile? Well, you can divide the data into each 1%, or you can divide into 25%. Kind of like, think about the money dollar. Well, there's a dollar bill, but you can also make that dollar bill by looking at each penny, right? 1 penny, 2 pennies, 3 pennies, all the way up to 99, and then 100th penny will make 100%. So same thing. Percentile is like thinking about making that 100% into a pennies. So piece of 21 means 21 pennies. So you have a 21 pennies, and then the other half will be 100 minus 21, so which is 79 pennies. Now, penny is not the only way to break the dollar. You can also make you can break the dollar into quarters. That's the concept of a quartile. Quartile represent the 25%. So in other words, I could say piece of 25 or Q1. 25 pennies is basically equal to 1 quarter. So piece of 20, Q sub 2 is equal to P sub 50. Q3 will equal to P75. Now Q2 is also known as the median, the middle value. So whenever I say find Q2, that's the same thing as finding P sub 50 or find the median value. Okay. Let me talk about the inner quartile range first, and then I will go back to the converting percentile. Now, inner quartile range, IQR, is the number that indicates the spread of the middle half or the 50 data value. So IQR is a difference between Q3 minus Q1, which is P75 minus P1. So I'm looking at kind of like the middle part. So if you're looking at this one, here's the 0. And then here's my 100%. Here, let's say P25, P50, and then P75. I'm basically looking at this, the difference between the Q3, Q1. Why are we interested looking at the IQR value? Well, IQR can help to determine potential outlier. What is an outlier? Outlier are some extreme data value. Now, the extreme data value can locate it at the high end or the low end. So at what point do we start calling that data an outlier, extreme value? So this is how you calculate it. A value is an outlier if it is above Q3 plus 1.5 times IQR value or below Q1 minus 1.5 times IQR. So here is Q3 and I'm going to add some more 1.5 times IQR. So I'm looking a little bit more value here. And then Q1 subtract the 1.5 IQR, whatever the number is. It's going to be subtracted, so I'm going to have a smaller number. Now, any data value within this green area, this is called normal. Okay? Anything outside that, that's an outlier value. Any data below that is called outlier. I'm totally making this number, okay? Let's say you have a IQ score of 150, okay? And you want to know if this is in normal range or outside of the normal range, like an outlier, then you need to calculate these two numbers, which is the boundary, and then see if 150 is inside here or outside. If it's inside, it's still normal. If 150 is above that normal range, then we call it an extreme value. So we'll also check the outlier on the next example. Now, going back to converting a percentile to a data value, well, if we went forward, finding the percentile data value, so what data value is representing 25%. Now I can go back asking the other way. What is P sub 25, right? Find the value of a 25th percentile. Then I'm looking at the data value. I want to find out the actual data value. So this one here, there's a 3 steps. Sort the data in order of lowest to highest. Compute I, we call it locator that gives position of a value. I is defined as a k over 100 times n plus 1, where k represents the percentile, kth percentile. This will be given on your problem. I is the index or the position of the data value, and then n is the total number, also known as a sample size. Now, there's a typo. This is not a L, I. It is I a whole number. If it's not a whole number, round I up and I value down to the nearest integer and average the two data value of these two position in order data set. That will give you that actual data value that represent that percentile. If it's a whole number, after you calculate it, if I is a whole number, then piece of k is the ith value counting from the lowest. I know this sounds really confusing. Okay, so I'm gonna jump right onto the exercise problem, which helps you understand all these that we just talked about. Okay, so let's take a look at the following example. The table 3.1 below lists an IQ score from the data set 6, Appendix B. Find the percentile of an IQ score with 96. Any outliers? Okay. Here, so I just worded again, A, find the percentile of the IQ score 96. Part B, just more practice, finding 18th percentile, piece of 18. Also, they're asking you to calculate piece of 25 or all the quartiles. And then lastly, check if there's any outliers. Okay, now I want you to note that A versus B and C is a different thing. A is asking you to find the percentile. So there's a data value 96. So 96 is the data value. Okay, well, in fact, there's a 3, right? they want to know 96 is a what percent of a data, so position, right? Oh, it represents 50%, 40%, 30%, okay? Versus B and C, this is percentage. So they give you the percentage value, 18%. You're trying to find the data value that represent the 18%. Now, before we jump right onto the question A, B, C, D, I want you to think about this and then kind of use common sense. There are 20 datas here. If you count 1, 2, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then another row, 20 data. So, well, each data 1 out of 20, that's about 5%. So each data value represents 5%. So if I include 2, that represent 10% of data, 15%, 20%. So 96 is 1, 2, 3, 4, 5, 6, 7, 8th position. So it's not all the way up to 10. So I'm expecting the 96, not including the repeat, this one to be less than 50%. So I should have less than 50% when I calculate. So 5, 10, 15, 20, 25, 30, 35. So between 40 to 45, 40 to 50%, okay? So 18th, well, the data value 18, well, remember this is 5, 10, 15, 20. I'm expecting the piece of 18% to be a data value between 87 to 88, okay? So I'm expecting data value between 87 to 88. I'm gonna actually write down this on the left and then check it to see if our prediction was correct. Okay, same thing, piece of 25, that's a 25%. So 5, 10, 15, 20, 25. So should be around here. Okay. 50% of the data, okay, 50%, remember this quartile, oops, I forgot to write down one thing about the quartile. Note, quartiles may or may not be part of the data. So 50%, you know it has to be right in the middle position. So if there's 20 data, where's the middle value located? Well, you can go through eliminating, right? So I'm gonna use a different color to help you guys see better. So from low end to the high end, and then this is kind of like what you did in, right? And then in algebra class, here the third one, the highest one, and then 88, and then the next one. So going from all of them, eliminating here, here, okay, and then 103, and then 94, and then 101, 96, and then 96. Whoops, why is it not working? Looks like my screen just froze. Give me 1 second.